Okay, let's unpack this.
Right, so today we're diving deep into a specific corner of enterprise security.
And this is way past your typical consumer-grade camera. We're talking true mission-critical hardware.
We are. We're dissecting the AXIS body-worn live solution, specifically that really demanding self-hosted deployment.
So our mission here really is to cut through the complexity.
Exactly. The source material for this, it's basically a technical blueprint for network engineers. So we want to provide you, the listener, with a clear understanding of the architecture.
And maybe more importantly, what it actually takes, logistically and technically, to run this kind of system yourself.
Yeah, and the hook is that we're moving completely beyond just passive recording.
This is real-time command and control.
It is. The system is designed to securely deliver live video, audio, metadata, everything, from the person on the ground to an operator who could be miles away.
Which completely transforms decision-making in these high-stakes situations. This isn't just surveillance, it's immediate situational awareness.
It's a fascinating requirement, really. When an organization decides they have to maintain total control over their data, they're willingly signing up for this level of technical complexity.
Because the payoff is just non-negotiable for them.
That's right. Immediate intelligence, command certainty, it's worth the headache.
So let's start with the basics. The operational core here is AXIS Body-Worn Live, or ABWL.
And its main job is to stream live video and audio securely. It can do this over standard Wi-Fi or, mobile networks.
The documentation really pushes this idea that it provides the wearer an added sense of safety.
Well, and there's a feature that really drives that home. It's what they call the never feel alone concept.
Explain that.
So when a camera wearer has an incident, something is escalating, they can initiate a live stream. It's usually just a double press of a button.
And the operator doesn't just get a silent video feed.
No, not at all. They're immediately notified. They can view the stream, assess what's happening, and then, this is the crucial part, they can explicitly acknowledge to the wearer that they are watching.
And the person in the field knows this instantly.
Instantly. The camera vibrates and beeps.
So they know headquarters has their back. They can just focus on the situation. That's a critical feedback loop.
It really is. So for any organization looking to deploy this, the first big decision is infrastructure. They have two main options.
Okay.
The first is the Axis-hosted option. It's the convenient one. Cloud-based, hands-off, high availability, end-to-end encryption.
Full GDPR compliance, all that good stuff.
All of it, right out of the box.
That sounds like the obvious choice for 99% of businesses.
It is. But we're here to deep dive into the other one, the self-hosted solution.
This is where the organization hosts everything on their own network. Why on earth would anyone choose that massive undertaking?
It almost always comes down to mandates. Yeah, the key driver is either strict internal rules or, more often, specific government regulations about data sovereignty.
So they're legally prohibited from using a cloud solution for this kind of data.
Exactly. By choosing self-hosting, they ensure that video evidence never, ever leaves their control, and they can integrate it directly into their own VMS, their video management software.
So control comes at a significant technical cost. Let's get into the guts of that architecture. This is where it gets really interesting because it all leans on WebRTC technology.
It does, yeah. And WebRTC is fantastic for low latency streaming directly in browsers. But getting that encrypted peer-to-peer connection to work inside a secure, walled-off enterprise network, that's the biggest challenge of the whole thing.
So how does the system manage the initial introduction? The camera and the operator's viewer are basically strangers on the network.
That's the perfect way to put it. It's an introduction. You have a few key components. You have the body-worn camera, of course, and the WebRTC client, which is just the operator's viewer.
And they don't know how to reach each other?
Not directly. So they need an introducer, like a secure switchboard.
A switchboard, okay.
And that role belongs to the live self-hosted server device. This could be something like an AXIS W401 activation kit. And on that device, it's running the live self-hosted server app.
So the app's first job isn't even to handle video?
No, its first job is just to set up the handshake. The blueprint calls it WebRTC signaling. It's a secure exchange of network information, so the two devices can discover the best way to talk to each other.
And once that signaling is done, the system shifts to its preferred mode, which is
encrypted peer-to-peer communication.
that direct path. That's vital.
Oh, it's everything. That's the engine that delivers that low-latency video. The camera streams encrypted video straight to the client, bypassing any middleman servers. It's fast, it's efficient, It's secure.
But if that direct line is blocked,
Then the system has a dangerous contingency plan.
which is the source of so many troubleshooting headaches, I bet.
Absolutely. If peer-to-peer fails, and this is usually because a firewall is too restrictive, the devices default to using the app's turn server as a relay.
And the documentation says this is not recommended.
It says it in bold. It's not recommended. Think of it like a manual relay. It adds delay. It chews up way more bandwidth on the server. It's just suboptimal. For this to work well, you need P2P to succeed.
So getting that initial setup right is absolutely critical. The source materials talks about a quick setup versus a manual setup.
Right. Quick setup is really just for demos, a proof of concept. It gets you running fast, but it hides a lot of the complexity.
Which is dangerous for a real deployment.
Very. The source warns that for any large or advanced network, you have no choice. You have to use the manual setup.
And that sounds incredibly labor-intensive. What's the real risk if a technician rushes this part?
The risk is catastrophic failure during a critical event. I mean, manual setup demands meticulous preparation. You have to prep the server device, make sure it has the latest OS, and you have to generate and apply a specific configuration file from the body-worn manager.
It's not a quick process.
Not at all. And none of it even starts without the licenses, which, surprisingly, are managed through this external multi-step process. It's not just typing in a key.
Oh, this sounds frustrating.
It can be. You have to export a system file from your internal manager, upload that to the external AXIS license manager website, wait for it to generate a license file, and then import that license back into your system.
Wow. That's a whole administrative hurdle you have to clear just to get started.
It is. And the license count is based on a strange metric, too.
It's not just how many cameras you own.
No. It's determined by the average number of cameras assigned to live streaming profiles over the last 7 days.
Huh. So that encourages security directors to be very specific about who gets live streaming enabled and when.
Exactly. It forces them to actively manage usage to minimize their licensing costs. It's a strategic detail, not just a technical one.
Okay, so the system is running, it's licensed. The final step is getting it into the VMS, like Milestone X Protect, so an operator can actually use it.
And this is where the payoff is. The operator connects to the self-hosted server right through an extension in the VMS taskbar. Simple IP and credentials. Now they have visibility.
But for automation, to make the system reactive, to trigger an alert when a stream starts, you have to do more, right? The VMS needs to be told to listen.
Absolutely. It doesn't happen automatically. To create a rule or an alarm, the administrator has to explicitly go into the recording server settings and add the device events live stream started and live stream stopped for the camera.
That one small step is the crucial link between a button press in the field and an alert in the control room.
That's the one.
So what does this all mean for the IT team on the ground? This whole system relies on that P2P communication, so the network environment has to be, what, surgically precise?
That is the perfect word for it. This is where the whole thing goes from an interesting concept to a mission-critical difficulty. The network demands are non-negotiable.
Like what?
Well, professional setups should use segmented networks. You need to isolate the body-worn controller and VMS from, say, general office traffic. You also need really robust Wi-Fi with access points that support things like 802.11k, V, and R.
To make sure the cameras can hand off between access points without dropping the stream.
Exactly. And then you need the minimum services just to get the lights on: DHCP, DNS, NTP.
But the biggest planning point, the one that needs budget approval, has to be throughput.
Bandwidth is paramount. And the source gives us hard numbers. You need a dedicated throughput of 2.5 megabits per second for a 360p stream.
Oh.
Or 8 megabits per second for the higher quality 720p stream. And that's per body-worn camera.
8 megabits per camera. That's a huge capacity sink. If you have 50 cameras and an event triggers half of them.
You are demanding a guaranteed 200 megabits per second pipeline minimum just for those live streams.
That is a massive infrastructure commitment.
It is. And the network has to treat that as guaranteed capacity. Because if the network chokes, the video just degrades. WebRTC uses UDP, which is fast, but it doesn't guarantee delivery. So when you hit a choke point, packets just get dropped.
So the operator doesn't see a buffering icon, they see a pixelated, freezing, jumpy mess.
Exactly. The system sacrifices smooth quality to maintain real-time immediacy. That's the trade-off.
Okay, let's talk firewalls. We need to list the mandatory ports that have to be open for this all to work, specifically inbound to that server device.
Right. These are the gates that absolutely must be open. First, for the camera to signal its presence, you need TCP 8082.
Okay.
For the system to figure out public IPs, a function called SDON, You need TCP and UDP 3478. Think of it like a directory lookup.
And what about location data and other status info?
That uses a protocol called MQTT over TCP 8883. And finally, the main VMS communication and signaling happens over standard TCP 443.
Those are the inbound essentials. What about the actual P2P video stream going outbound from the camera?
That's the biggest firewall hurdle for most places.
Yeah.
Outbound PDP uses the high ephemeral port range.
Which is a huge range.
Massive.
Yeah.
TCP UDP ports 49152 all the way up to 65535. If that range is blocked, you can't establish P2P. You're forced back to that high latency turn relay.
Okay, let's move beyond the setup to daily use. What are some of the features that make this powerful for operators?
Well, they can initiate a stream remotely. If that's enabled for the user, they can create custom views, mixing live feeds with maps.
Oh, that's useful.
It is. And for large groups, nearby wearers are clustered on the map, so you can see at a glance where your teams are.
My favorite feature I saw was the trails.
Ah, yeah, the trails are great. It shows the wearer's movement path over the last 20 to 30 seconds.
So you get immediate historical context for what happened right before the stream even started.
Exactly. But these complex systems, they are prone to some very specific, very frustrating failure modes.
Let's talk troubleshooting.
Okay.
What's the #1 cause of failure that sends technicians on a wild goose chase?
Time synchronization.
Time, really?
Yes. If an operator sees a security certificate that looks like it's expired, the source says the root cause is almost always that the clocks are out of sync.
Yeah.
The camera, the server, the VMS, they're all on different times.
So a scary security error is actually just a clock error.
Most of the time. The fix is just defining a proper NTP server for the whole system. That one tip could save an IT team days of work.
Okay, what about diagnosing an actual network failure? The stream shows up in the list, but it just won't connect.
Right, you get that can't communicate with device message. That usually means all the attempts to find a network path have failed. WebRTC couldn't negotiate a route.
And those attempted routes are called IC candidates, right?
That's the jargon, yeah. The system tries all these potential paths, stun, turn, direct connections. If they all fail, a firewall is blocking the negotiation. You'd have to use network analyzers or even browser tools to see where the packets are dying.
And let's quickly touch on LTE. Using mobile streaming adds a whole other layer of complexity.
It really does. You've got new points of failure. Is the SIM card locked? Is the IMEI blocked?
Yeah.
But the biggest headache is often the access point name, the APN.
Which is set by the mobile provider.
Right. And if the camera can't get an IP address on the mobile network, it almost always means the required APN is missing or wrong. And that has to be manually configured in the body-worn manager.
So you need tight coordination between your IT team and your mobile carrier before you even think about deploying.
You absolutely do.
So this whole deep dive really underlines a huge strategic trade-off, doesn't it?
It does. The self-hosted solution offers that total organizational control, that deep VMS integration, everything some agencies absolutely require.
But that benefit demands meticulous, just surgical network planning.
It's a huge commitment. You need guaranteed bandwidth, you need every single port to be visible to the right devices, and you need to maintain strict time synchronization across everything.
You know, this deep dive reveals that the greatest vulnerability in a complex system like this, it's often not the high-level encryption.
No, it's the basics.
It's the infrastructure. It's whether the right firewall ports are open or if every single clock is perfectly synced. So if the system goes dark, is the first step calling IT? Or is it checking your camera's IMEI status and your APN settings?
That shift in mindset is what separates a cloud user from a successful self-hoster.
Something for you to mull or explore on your own.
Thank you for joining us for this deep dive.